let us start this lecture with a thought process from Eisenhower, who was an important American Army general, and later on he became President of USA, and he fought a war as a General of Allied Command, and who says, every gun that is made, every warship launched, every rocket fired signifies in the final sense a theft from those who hunger and are not fed, those who are cold and are not clothed. It is a very important statement from a person who was instrumental in leading a Second World War, and that is the fact that we spend a lot of our resources for having a war in future at this moment. And of course, we can use the rocket for the civilian applications, like sending satellites and then going for a deep space voyage. That is okay, but however, we should not misuse, abuse the resources and also put the people in stake and in the name of war. So, let us recall what we learned in the last lecture. In the last lecture, we discussed about various historical aspects of the rocket engine, how it was evolved from the finding of gunpowders, and later on how it was evolved. Of course, now it is in a very higher state of technologies, and we will be looking at some fundamentals. And later on we moved into how the space research program of India was evolved, and we are having a very ambitious program of the space research in which rocket engine plays a very important role, and therefore it is interesting and important for us to learn the fundamentals of rocket engine. Today we will be discussing about various types of rocket engine that already we have discussed. Let us recall that what are the types of rocket engines we can have, and it can be broadly divided into two categories, as we learned earlier, that is chemical rocket and the non-chemical rocket. And we will be mostly dealing with chemical rocket engines in this course, and as I told earlier, toward the end we will be maybe touching upon various aspects of non-chemical rocket engine. The chemical rocket engine is further divided into three categories based on the type of propellant is being used. First is the solid propellant rocket engine, and liquid propellant rocket engine, and hybrid propellant rocket engine. Hybrid is basically both the solid and liquid are being used in case of hybrid propellant rocket engine, and we will be looking at in detail as we go along. And non-chemical rocket engine again further divided into the three categories based on the type of fuel is being used in this engine, that is nuclear rocket engine, electrical rocket engine, and solar rocket engines. So, let us look at a solid propellant rocket engine as I have shown here. You can see that it is having various components. As I told earlier, this is a nozzle, which is very important aspects, because in this case it basically hot gas is expanded through this nozzle for producing thrust, and beside this, for producing this high pressure, high temperature gas, we need to burn the propellant. This is your propellant portion, and which is having particular shape, and that is, we call it as a grain, and it is contained in a casing and with a liner that will protect the heat, and also it will make it to be compact with the casing. And in order to initiate the combustion, we could have an igniters, and which will give initial energy for the starting of combustion of propellant. And this high pressure and temperature gas will be expanded through the nozzle and then and which will produce the thrust. Let us look at how it is a liquid propellant rocket engine looks like. It is quite complex, as you can see from this diagram. And it is having, of course, the fuel tank, oxidant tank, and it is having this propellant feed system, which is having a pump, and this is your turbine. T stands for turbine, and it is having also a gas generator and having valves. These are basically controlling valves, and it will be there for also the fuel tank. And if you look at it, is quite complex in nature as compared to the solid propellant rocket engine, right. So, therefore, it is being used routinely for particularly higher stage operations, and as you go along we will see in detail. And let us now look at basically solid propellant rocket engines, as I discussed earlier. So, it will be having basically 4 component. One is casing. This is your case or casing, right. This is your casing, in which the propellant, solid propellant of proper shape and size is being fitted into with the help of the liner. This portion is your liner, and this is your propellant, as I mentioned earlier. This portion is your propellant grain, and this we also call as a propellant charge, because this both the fuel and oxidizer content in this propellant, and that this is your igniters, which will help in initiating the combustion process by providing initial ignition energy. And nozzle plays a very important role for expanding the high temperature gas. This gas will be high temperature gas, high temperature and pressure gases, which will be produced here, and it will be passing through this and expanded nozzle for producing the thrust. So, as I told that grain plays a very important role because of fact that propellant grain burns in a predictable manner and produces the high temperature and pressure exhaust gas that is expanded in a nozzle. So, sometimes we call solid rocket engine as a rocket or a motor, because it contains the propellant charge necessary for combustion within the combustion chamber that cannot be shut off once ignited. That is the limitation of the solid propellant rocket engine. However, of late there is a provision of shutting the solid propellant rocket engine, and which can be throttled and extinguished, and also can be reignited if necessary. Modern designs include steerable nozzle for guidance and control, and one can also recover the hardware through the parachutes, and one can also have provision to have a attitude control with the help of small motors, and there is a provision of thermal management of the materials and other things. These are all in the part of advanced rocket engines. Generally, it is not possible really to control the or set off the rocket engine once it is ignited. So, what we will be looking at, we will see that about how it is the advantages and disadvantages of solid propellant rocket engine over the liquid propellant rocket engine. And solid propellant rocket engine we call SPRE, we will be using it, and similarly liquid propellant rocket engine we call LPRE in short form. So, it is a simple to design and develop, that we have seen. It is having a very less number of components as compared to the liquid propellant engine. It is liquid propellant engine is quite complex in nature, as we had discussed earlier, and we had seen its schematic diagrams, and it will be having feed system, it will be having pressurizing system, it will be having ignition system, which I didn't discuss. Beside this injection system, and there are several complexities involved in that. And solid propellant rocket engine is easier to handle and store the solid propellant, unlike the liquid propellant, and it is easier to fire. For firing or igniting the liquid propellant rocket engine, you need a lot of preparation, which is not the case for solid propellant rocket engine. And detonation hazards of many modern solid propellant rocket engines are quite negligible. One cannot rule it out, but it is quite negligible because of certain provisions of safety being incorporated in the modern solid propellant rocket engine. And it has a better reliability than that of the liquid propellant engine, and some people claim to have reliability of order of something 99%, which is quite high, and it is much easier to achieve multi-staging of several solid propellant rocket engines, or the motors, what we call. Engine and motor will be using interchangeably, although there is a small difference between that. And nowadays people are using more as a rocket engine as compared to the rocket motors. So, the combustion pressure in solid propellant rocket engine is generally much higher than in the case of liquid rocket engine, because of fact that it is not having the limitation of a feed system. And as we go along, we will be learning more about it. Because of feed system in the liquid propellant rocket engine, we cannot go for a high pressure operation. And also the another problem will be there for in liquid rocket propellant in liquid propellant rocket engine, not to go for high pressure, is fact that thickness of the combustion chamber will be higher, as the flame will be really coming in contact with the wall of the combustion chamber. In case of solid propellant rocket engine, the flame will be contained inside the grain, which is quite thick one to start with. And the developmental and production cost of solid propellant rocket engine is much smaller as compared to that of liquid propellant rocket engine, especially in the higher thrust level whenever. And let us look at disadvantages of the solid propellant rocket engine. And it has a lower specific impulse as compared to the liquid or the hybrid propellant rocket engines. In spite of this low specific impulse, it is being used in the booster stage, that you should keep in mind. And it is difficult to turn off its operation, unlike the liquid propellant rocket engine. However, in modern times, people have devised ways and means to shut it off even during its operation. Transport and handling of solid propellant are quite cumbersome because of various safety reasons, and also in modern days the people are involved in this terrorist and other activities, then theft of the propellant is one big problem. And it is difficult to use the thrust vector control and thrust modulation which is required for the maintaining the proper trajectory, and which is quite difficult to incorporate. And the cracks on the propellant which is may likely to occur due to various reasons of aging or maybe bad design and then stress can cause an explosion, and which must be avoided at any cost. So, the careful design of nozzle is required because we cannot use the acting cooling as in the liquid propellant rocket engine. So, therefore, the nozzle has to be designed properly, as we can use only the passive cooling. In case we may be discussing about that little later on. The erosion of throat area of the conversion diversion nozzle due to the presence of high temperature solid particles can affect its performance adversely, because the solid propellants will be burned in the combustion chamber. There is a likelihood of some particulate will be there, and which will be at very high temperature, and beside this the metal loading is being used to enhance the specific impulse of the solid propellant rocket engine. Therefore, this metal which will be very hot and will be at high velocity may go and impinge into the surface of the high temperature nozzles, and that may corrode the things, and also it will be affecting the performance of the rocket engine. So, let us look at liquid propellant rocket engine, and you can see that it uses basically various kinds of propellant. We will be discussing little later on, but just to give an idea, we will be using the monopropellant rocket engines, bipropellants, and tripropellant rocket engine. It can be liquid propellant engine can be divided into basically three categories based on the kind of propellant is being used. Bipropellant rocket engines is one in which liquid fuel and liquid oxidizer can be used, whereas monopropellant is a single propellant will be used as a propellant which will be acting both as a fuel and oxidizer. And the example is of the bipropellant rocket engines which is being used nowadays very much due to its high impulse is the liquid hydrogen and liquid oxygen, and which is also known as the cryogenic engine. Liquid propellants are also used in hybrid rocket engines that we will see. Let us look at a schematic of a very famous engine as I have shown here. If you look at this picture, you can see a lot of components are listed on this. You can see that start with it will be having payload, and basically that is warheads, and of course the control and other thing you are having automatic gyro control and guide beams and radio command receiver, so that you can have a control kind of thing, but these are basically can be considered as a payload. This portion is basically you can say that this is for the payload. But from here the rocket engine starts, and it is having a alcohol and water which was used in this, which is used in this rocket engine is as a fuel, and you are having liquid oxygen here, and it is having rocket body. Now, if you look at the major portion of this rocket engines is the larger length is being occupied by the fuel and oxidizer and payload, and the engine is quite small. So, this is your combustion chamber, rocket combustion chamber, and this is having your nozzle, like this is having your nozzles, and of course this is your alcohol inlets, which will be there part of entering into the nozzle, and then it will be getting into, and this is your, beside this you are having propellant turbo pump, and there will be also the turbine, and there is a hydrogen peroxide tank which will be there. Now, if we are using alcohol and water mixture as a fuel and liquid oxygen as an oxidizer in this liquid propellant rocket engine, why we will be using hydrogen peroxide? The answer is that we want to ignite it, and hydrogen peroxide can be used to basically produce some high temperature and pressure gas, such that it will be igniting the mixtures. And this is your thrust frame, and of course there is a air vanes and jet vanes for the control, and this is your wing, this is the control surface. And if you look at, we are having compressed nitrogen pressurizing bottles, which is required to start the engines, right. And this is you can recognize that is a famous V2 liquid propellant rocket engine that was developed by German and used during the Second World War. Although as I mentioned earlier, the German lost the war, as a result the scientists, engineers who developed the rocket missiles and then rocket engines were migrated to the America and also to Russia. As a result, both the countries which were in the Cold War later on, their space program and the rocket programs flourished very well with the technology and the ideas and the acumen by the persons who had migrated to their country. So, let us now look at what are the advantages and disadvantages of liquid propellant rocket engine over the solid propellant rocket engine. Liquid propellant rocket engine can be used and reused very easily, and it provides a greater control over the magnitude and direction of the thrust, unlike the solid propellant rocket engine, because of fact that the thrust vector control we cannot adopt there very easily, and here we can use it very easily, and it can have a higher values of specific impulse. As we go along, we will see it is much higher as compared to the solid propellant rocket engines. In case of emergency, its operation can be terminated very easily, unlike the solid propellant rocket engine. It can be used on pulse mode, unlike the solid propellant rocket engines. However, in present day, that solid propellant rocket engine has been designed by using different kind of propellant gains, such that it can be operated on pulse mode. It can be used for long duration applications, depending on how much propellant you can carry, and beside this also the provision can be made to refill it if it is required. It is easy to control this engine, as one can vary the propellant flow rate easily, unlike the solid propellant rocket engine, and the burning rate is not that easy to control unless it is designed a priori. The heat loss from the combustion gas can be utilized for heating incoming propellants, which will be used particularly for cooling the nozzles, that we will be discussing later on. As a result, it will be more efficient and the energy being utilized properly. So, disadvantages, if you look at, this engine is quite complex as compared to the solid propellant rocket engine, but however, the space requirement for the storing the propellant is quite high, so also the feed system and pressurizing system. It is less reliable as there is a possibility of malfunctioning of turbo pump and turbine, injectors and valves, because there are several components which are being used as we had seen earlier. So, certain liquid propellants require additional safety precautions which must be taken care, otherwise it will lead to the hazardous, and it takes much longer time to design and develop of these engines, and because its components are quite complex to design and also the manufacture. So, it becomes very heavy, particularly for short range applications, and it is having several components. So, let us look at the hybrid rocket engines. In case of hybrid rocket engines, generally the liquid oxidizer is being used, and it is having a combination of both the solid propellant and liquid propellant. In this case, there will be igniters, there will be injectors like a liquid propellant rocket engines, that system will be there, and beside this will be having solid propellant. These are basically solid propellant grains which will be there, and then this will be burning, and then of course the high temperature and pressure gases will be produced in this zone, combustion zone or combustor, and which will be expanded in the nozzle such that we can produce the thrust, and it is having certain advantages over the both the solid and liquid propellant engine. As I told earlier, it uses propellant with two different state of matter, one is solid and other is liquid, or the gas can be used also. The hybrid rocket engines has advantages over both liquid and solid propellant rocket engine, especially in terms of simplicity and safety and cost. Of course, it is much simpler as compared to the liquid propellant engine, but however it is complex in nature as compared to solid propellant. It is in between both the solid and the liquid propellant engine. Let us look at the advantages. Hybrid propellant engine can be reused easily, and it provides greater control over the magnitude and direction of the thrust. It has a relatively lower system cost as compared to the liquid propellant rocket engine, being fact that it is having the fuel feed system and pressurizing system won't be there. It can have higher values of average specific impulse as compared to solid propellant rocket engines. It has higher density specific impulse than the liquid propellant rocket engine. It has a higher volume utilization as compared to the liquid propellant rocket engine. It has start, stop and restart capability, unlike the solid propellant rocket engine. Disadvantage: this engine is quite complex as compared to the solid propellant rocket engine, and its mixture ratio varies to some extent, hence is quite difficult to achieve a steady state operation. It has lower density specific impulse as compared to the solid propellant rocket engine, and sometimes or in many times the solid propellant is not being utilized properly due to remaining of the larger slivers of the grain at the end of operation. Therefore, it is not really very cheap or the efficient one, and certain liquid propellants require additional safety precaution, and it takes much longer time to design and develop like the liquid propellant rocket engine. It becomes heavier, particularly for short range application. It is not being used very much in practical application. Therefore, it considered to be unproven propulsion system for large scale applications. However, people are working on it, and then in future it will be used profusely, as I could see that. Let us discuss about the applications of rocket engines. A question might be coming: what are the applications of the rocket engines that you can think of? Generally, if you look at, you can say that it is basically space application, or we can have a space launch vehicles. Then other application will be deep space mission such that we can use our spacecraft, and other one we can use particularly for missiles. These are the three common applications what one can think of, but beside this it can be used for several other applications that depends on the imaginations and your innovativeness of the mind of the people and their also necessity. So, the research airplanes, it is being used routinely, and even I remember for the scramjet engine, for testing of scramjet engine, the rocket engine is being used. The ejection of crew escape capsule from the spacecraft, it is being used, and propulsion belts, which was really having a commercial application. Some people in USA, they were developing it as a commercial venture to experience the elation of floating. And propulsion for target drone, which is being used routinely, and signal rockets for sending the signals to other places we can use, sounding rocket for basically studying the atmosphere, and we use it routinely, and vernier rockets, which is used as a vector control, thrust vector controls, and spin rocket engine is being used, and throwing lifelines to the ships which will be in turmoil, particularly in tornado and other things where you cannot really move, but you can use some lifelines to the ships. Even in India, we can use rockets, particularly during the flood or any mishap where you cannot access the people, you can send the food and other materials to save the lives of people marooned in the flood or some other things. So, which will be stop over here, and the next lecture will be discussing about the aerothermodynamics related to the rocket engines, or which will be useful for the rocket engines. We will be discussing about fundamentals of aerothermodynamics that can be utilized for the rocket engine. Thank you very much.